Okay, here in this part of the video, this is the most important part of all the videos, by the way. Why? Because here I'm going to explain to you the concepts underlying standardizing a variable x. Okay, and why do we do that? Or in fact, how this will help us then to find the probability of x being within any range. So I'm going to show you how we're going to switch between the PDF of a variable x to the PDF of another variable, which we called in the previous slide the standard normal variable, right, or the unit normal variable. So if x is a variable that has a normal distribution, so we said that we're going to denote this as x with that tilde with normal n for normal distribution, and then these are the two parameters, mu and sigma. So remember, mu and sigma are given. Okay, usually you get these from historical data. Okay, so this is the curve, or this is the PDF representing x. So you can see that the x, or this axis, the horizontal axis, represent the axis for x, meaning that these are all possible values of x, and it's symmetrical with respect to the mean, which is the mean of x, okay, the average. So this curve will allow me then to find the probability of x is less or equal than a value, any value. I'm going to call it x star, usually call that the critical value, which is any specific value that you are interested in. Okay, why? Because you have a certain question in mind, and you want to answer a question like this. For example, what's x probability that x is less or equal than 5? Okay, this will be x star for you, your critical value, a value that you want to find its probability. So where is x star? I can take any value. Just for illustration, I will take it here. So this is your x star, okay? And the probability that x is less or equal than x star, how do we find it? Yes, it's equal to the area under the curve. So it is that area. Let's call that area A star, just because we called x star. Now this area is A star. So which means that P of x less or equal than x star, this is A star, right? Just find the area, so you answered the question about the probability. But as we said before, it's very hard then to do that for any combination of mu and sigma. Finding the area is really time-consuming exercise. We don't want to do that. Okay, so we don't want to do this this exercise, but instead we're going to find the area under the standard variable z, right? So what is z? Z is a variable that has a normal distribution, but it's a very special distribution. And when I say very special distribution, I'm referring to the parameters. Okay, these parameters are peculiar. Why? Because z has a normal distribution, and the mean is equal to 0, and standard deviation is 1, right? This is why it's also called the unit normal distribution or standard normal distribution. So on the curve, okay, it looks like that. Okay, so I have now z is my horizontal axis, and the mean here is 0, as we mentioned above. And what do we want to know is we want to find the areas under this curve. Why? Because, as I told you, statisticians did this exercise for us. Because we have this very peculiar curve that has a mean of 0, standard deviation of 1, they did this exercise of finding the area for any value of z. Okay, so the question is here, how do I find the value of z that correspond to my critical value x star? And this is what we mean by standardizing x. Okay, so we standardize x, meaning that we find for any value of x its corresponding value z. Okay, any value. So let's see what would be then how do we standardize x star? Okay, we're going to standardize any value using this equation. This is, if you want, a very important equation, the z equation if you want. It gives us the equivalence for any value of x, its equivalent value in z. Okay, so for our example here, where x star, we're interested in x star, we want to find z star. So z star is, I substitute x with x star. Mu and sigma are constant for that variable. Okay, mu and sigma are known. So for any value I'm interested in x, I can find its corresponding value z. So look at this. Z star correspond to x star, which means what? Which means now I can convert my probability statement that I did on the top in terms of x, right? P of x less or equal than x star. I can show that in terms of z. So here we go. How did I do this? What I did is, this is my original probability statement. Then what I did, first I subtract the mean, and I did that for both component, and then I divided by sigma, and I did that for both parts of the inequality. So, and I ended up with that. Now, what do I know about this part? This part is z. Here we go. And what do I know about this part? This part is a specific value of z corresponding to x star, which is d star, meaning that now in order to find the probability that x is less or equal than x star, all what I have to do is what the probability that z is less or equal than that z star, and z star, I know it. Here we go. I have found it here. So I will find now this area, and this area is what? It's a star, and this will be the probability that z is less or equal than z star. And you see, this a star is exactly equal to that a star. Okay, now the question is, all right, now that I shifted to find the area from the x curve to the z curve, how can I find it? This is where we're going to use the z table. Okay, so as I mentioned before, the z table is a table that shows us for any variable, for any value of z, what's its corresponding area, a star. All right, and I'm going to show you how to read a z table in the next slides.